Good morning, everyone. Today is a wonderful day because we will be having a good news. The most awaited event of the century is now about to come. The one of the most successful global boy band is finally having their comeback. One Direction is on the road again. Niall, Liam, Harry, Louie, and Zayn decided to have their comeback concert in their three chosen countries. Concert will be called the Network Models. They will be traveling from one location to the other. For the details, network. So, network is an arrangement of paths connected at various points through which one or more items move from one point to another. Drawn as a diagram providing a picture of the system, thus enabling visual interpretation and enhanced understanding. So a large number of real-life systems can be modeled as networks, which they are relatively easy to conceive and construct. So the use of network is to provide a visual understanding or interpretation about a real-life situation. For example, there is a large number of real-life situation or real-life systems. So they will be needing a network so that we will have a visual interpretation for us to understand the situation and better solve the problem and provide solution. So network models is now become a very popular management science technique for a couple of very important reasons. So network models is the use of diagram or graph to help formulate and solve linear programming problems. Network models is also known as network flow program. It describes a type of model that is special case of the more general linear programming. So network model is under linear programming. However, network models focuses on a more special cases. So we could use linear programming, but if we use network models, it will be more efficient and effective to solve specific situations. So network models describes patterns of flow in a connected system where the flow might involve material, people, or funds. The system elements may be locations, such as cities, warehouses, or assembly line. Or if not location, it may be points in time. So when a situation can be entirely modeled as a network, very efficient algorithms exist for the solution of the optimization problem, many times more efficient than linear programming in the utilization of computer time and space resources. So as mentioned, we use computer in making network models because computer that is the one that we use to make our graphs and illustrations. So nodes and arcs. Network models uses nodes and arcs to make decisions. When we construct diagrams or graph to represent systems, the elements are represented by nodes or circle in the diagram. The path flow are represented by arcs or arrow. For better understanding what is nodes and arcs, here is the illustration. So in this graph here, itong mga circle na nakikita natin, itong 1, 2, 3, 4, 5, 6, 7, ito yung tinatawag natin na nodes. Itong mga lines naman na nagko-connect ng mga circles, ito naman yung tinatawag natin na arcs. So, the nodes and arcs, ito yung ginagamit natin na term sa ating network model. So here we have the types of network graph. The undirected graph, directed graph, and mixed graph. So first, we will discuss what is undirected graph. So as we all know, direction can be symbolized by arrows. So dito, ang pinakaibahan ng undirected graph from directed graph is yung arrow. Kasi sa directed graph, gumagamit sila ng arrow, which symbolizes direction. Dito sa undirected graph ay walang arrow. So, example na lang ng undirected graph is 1 is connected to 2 and 2 connected to 1. Si 2 connected kay 3 and 3 connected kay 2. So they are connected to each other. Walang specific direction kung saan nakakonect. Si 1 lang nakakonect kay 2 or si 2 lang nakakonect kay 2. Hindi. Si 1 nakakonect kay 2, at the same time 2 is connected to 1. Si 2 connected kay 3, and at the same time si 3 connected kay 2. So walang specific direction. They are connected to each other. So sa real life situation, ang example ng undirected graph ay yung Facebook friends natin. Kasi pag once naging friends na natin yung isang tao sa Facebook, doon sa kanyang account is friend din tayo. So it is reciprocated. Connected tayo sa isa't isa. So dito naman sa directed graph, as mentioned earlier, yung ang makikita natin ay yung kanyang arrow. It has a specific direction. So dito, si 1 connected kay 2, but 2 is not connected kay 1. So si 1 lang yung connected kay 2 kasi si 2 ang connected naman siya kay 3, connected siya kay 4, connected siya kay 5. Si 3, dyan lang siya, hindi siya connected kay 6, hindi din siya connected kay 2 kasi yung arrow is papunta lang kay 3. Hindi siya like sa undirected graph na reciprocated ang feelings. No, just joking. Hindi sila connected to each other because merong specific direction ang pag-connect. So example nito in real life is our Twitter followers and Instagram followers. Diba? Pag pinalo natin siya, hindi ibig sabihin na ipa-follow back na tayo agad. Minsan hindi talaga tayo pina-follow back. Nagpapa-follow lang pero hindi nagpa-follow back. Now, moving on, we have mixed graph. So as the name it is called, so mixed graph is the mix of directed graph and undirected graph. So merong directed graph and undirected graph. So ang example nito ay mga job scheduling, construction industry, project management activities. So gawin na lang natin in a real life situation is manufacturing. So sa pag-manufacture, itong si activity 4, activity 6, pwede silang mag-start ng pag-manufacture or paggawa ng kanilang process immediately, sabay, pwede. Pero si 1, hindi siya pwede mag-start unless natapos na si 4. Kasi kailangan matapos muna si 4 at ibibigay niyo yung finished product niya kay 1. Pag nalagay na kay 1, si 5 immediately pwede nang mag-start, pero si 3 hindi siya pwede mag-start. Kasi hintayin niya munang matapos si 1 before siya makaka-start ng kanyang process because of the direction, itong arrow na nagsisimbolize. So pag undirected graph, pwede silang sabay na mag-start ng process. Pero pag may directed graph, hihintayin muna matapos yung isa, tsaka siya makakapag-proceed ng kanyang process sa manufacturing. So network graph can be used in a manufacturing industry. So that is the details, that are the details of the said concert of 1D. So now the 3 lucky countries that the boys picked were minimal spanning tree problem, maximal flow problem, and shortest route problem. So these 3 countries are the lucky countries na napili ng ating boy band na kanilang i-visit for their comeback. So for more details, watch out kasi mamaya ibibigay natin ang more details na meron ang each location natin. So Directioners, go grab your tickets now!
Good morning, Directioners. For our first stop in the comeback concert of One Direction, we have here the minimal spanning tree problem. There are 3 things you must remember in order to easily understand this topic. First is, 2 nodes are connected if the network contains at least one path between them. Second, a connected network is a network where every pair of nodes is connected. And third, a path that begins and ends at the same node is called a cycle. Let's define first what is a spanning tree. First, it contains all the original graph's vertices, meaning all the nodes in a network must be present. Second, it reaches out to all the vertices, which means all the nodes must have a path to reach out on another node. Lastly, a spanning tree should be acyclic. In other words, the graph doesn't have any nodes which loop back to itself. For a network with n nodes, a spanning tree is a group of n-1 arcs that connects all nodes of the network and contains no cycle. Now, I'm going to show you how to identify if a network is a spanning tree or not. In this network, C is connected to D. The path is from C, A, B, and D, but C is not connected to G. As you can see, there is no cycle in this network, meaning this is not a spanning tree. We can also check it by using the n-1 arcs. N, or the number of nodes, is equal to 7. N-1 is equal to 6, and the number of arcs is equal to 5. The n-1 and the number of arcs is not equal, meaning this is not a spanning tree. In this network, all the nodes are connected. However, this network is a cycle. For example, there is a path from C back to itself, C, A, B, D, back to C, meaning this is not also a spanning tree. If we check it, n is equal to 7, n-1 is equal to 6, and the number of arcs is equal to 8. This is not equal also, so this is not a spanning tree. For our last example, all the nodes are connected. There is also no cycle since wala namang path na bumabalik sa same node. And if we are going to check it by n-1 arcs, n is equal to 7, n-1 is equal to 6, and the arcs is equal to 6. The n-1 is equal to the number of arcs, which make this network a spanning tree. The minimal spanning tree technique involves connecting all the points of a network together, while minimizing the distance between them. It has been applied, for example, by telephone companies to connect a number of phones together while minimizing the total length of telephone cable. There are three ways of finding the minimum spanning trees. We have Dijkstras Algorithm, Prim's algorithm, and Dijkstras algorithm. Dijkstras algorithm or Dijkstras minimum spanning tree. So what are we going to do is to keep minimum edges as long as no cycles are found. So first, piliun na to ang may cheapest edge, which is ang D to B ug ang F to G. Next is ang A to B ug D to E since 2 man ang iyahang edge. So, ang next nga minimum edge is ang B to E. Pero dili na to siya pwede i-appel since pag i-connect na to ang B to E, mag-create siya og cycle. So, mag-proceed ta sa B to G kay may minimum edge man siya nga 4. Ang path sa A to D is may edge siya nga 4 pero dili na to siya pwede i-appel since mag-create po siya og cycle. So, next is magpili ka 6, 7, ug 10. So, since mas gamay man ang edge diri mo niya tong pilion. We have connected all the vertices in our minimum spanning tree. To solve the weight of this spanning tree, we just need to add all the edges. So, para i-solve na to ni 1 plus 1 plus 2 plus 2 plus 4 and plus 6. So, we have the minimum spanning tree of 16. Now we have is the pre-minimum spanning tree. First step is to choose an arbitrary start vertex. Pilion ako ang A. The next step is to keep including connected edges. We have edges A to D, A to B, and A to F. So, mas kamay man ang edge sa A to B, mo niya nga to ang gamiton. Next, we have the edges B to D, B to E, B to C, and B to G. Also, B to F. So, we are going to choose the edge B to D. The edges connected to D is D to E, and D to A. Since dili na to pwede gamiton ang D to A kay mag-create siya og cycle, ang gamiton na to is ang D to E. We have edge E to B, pero dili na to siya pwede gamiton since mag-create siya og cycle between B, D, ug E. So, mag-proceed ta kay edge B to G ug A to D. Pero dili po na to pwede gamiton ng A to D kay mag-create siya another cycle. So, ang ato ang gamiton is ang B to G. So, we have here the edge of 1, which is gamiton na to. So, para makakonekta sa node C, pwede ta moagi kay G to C, B to C, ug ang E to C. Pero mas gamay man ang edge ni G to C, so mao atong gamiton. Now, we are going to measure the weight of this spanning tree. 1 plus 1 plus 2 plus 2 plus 4 and plus 6. So the weight for our minimum spanning tree is, our last example on how to get the minimum spanning tree is Dijkstras Algorithm. First step is to find the least weighted edge of each vertex. So we have all of these components, and we are going to identify the cheapest edge of each component. First, we have component A. So, A to B and A to C. So, we are going to use A to B. So, for component B, we have B to A, B to C, B to F, and B to D. But we are going to use B to A. Dili na to kailangan magbutang since na naman. So, for component C, we have C to B, C to D, and C to F. So, we are going to use C to B kay 6 ug 5 man siya, ari 4. So, our next component is D. So, D to B, D to C, and D to F. So, mas gamay man yung edge driya, so mao atong gamiton. Next component is E. We have E to D and E to F. So we are going to use E to F. So for our component F, we have F to C, F to D, and F to E. So na naman tayo gibutang diri ang arc, mo lang gyapon natong gamiton. So for component G, we have G to F and G to H and G to I. So we are going to use G to I. For our component H, we have H to E, H to G, and H to I. So mas gamay mo ni nga edge, mao atong gamiton. And for our component I, we have I to G and I to H. So na naman tayo gibutang nga arc diri mo lang gyapon natong gamiton. The next step is to combine the graph using edge with least weight. Next, so kailangan nato kompletuhon ang graph para tanan nga vertices is connected. So, since mas gamay man ang edge ni E to H, mao nga atong gamiton. As you can see, the graph is completed. Now we are going to compute its weight. So for our weight, we have 1 plus 1 plus 2 plus 2 plus 2 plus 3 plus 3 and plus 4. So the weight of this spanning tree is 18.
Thank you and see you at our next location.
So let's proceed to our next topic, which is the maximal flow problem. So what is maximal flow problem? The maximal flow problem entails calculating the maximum amount of material that can flow in a network from one location, which is the source, to another, also known as the sink. We can also use maximal flow technique because it calculates the maximum amount of material that can flow through a network. Also, numbers by the nodes indicate the number of cars that can flow from that node. Also, this maximal flow technique can be used to determine the maximum number of vehicles, such as cars, trucks, and so on, that can travel from one site to another across a network of roads. This can also determine the shortest way through a network. So here we have a problem that can show how to use maximal flow technique. So a small town in Wisconsin, which is called Waukesha is in the process of developing downtown road system. A city planner wants to know how many cars can pass through the town from west to east. So this figure depicts the proposed road network for the town. So to use maximum flow technique, we have to follow these 4 steps. First step is to pick any path from the start, which is the source, to the finish, also known as sink, with some flow. If no path with flow exists, then the optimal solution has been found. Our next step, or the second step, is to find the arc on this path with the smallest flow capacity available. We can call this capacity C. Also, this represents the maximum additional capacity that can be allocated to this route. The third step is, for each node on this path, decrease the flow capacity in direction of flow by the amount of C. And for each node on the path, increase the flow capacity in the reverse direction by the amount of C. Later on, I can furthermore explain this. And our last step is to repeat these steps until an increase in flow is no longer possible. So this is the proposed road network for the town. So our first step is to choose randomly in any this path. So we choose the very top one, which is the node 1 to node 2 and node 2 to node 6. Then the next step is to find the arc with the lowest capacity that is available going from the source to the sink. So what are these? Arc going from source to sink. So from node 1 to node 2, the arc here is 3, which means only 3 units can pass in this path. While in node 2 to node 6, the arc here is 2, means only 2 units can pass in this path. So compare the 2, which is the lowest, obviously it is the 2. So it means only 2 units or 200 cars can flow from node 2 to node 6. Now we adjust the flow capacities. As you can see in this figure, the lowest flow capacity, which is 2, subtracted from the direction of source to sink, which is 3 and 2. This is the arc, so we have to subtract the 2. That's why we come up with these answers. So 3 minus 2 is equals to 1, 2 minus 2 is equals to 0. Then in reverse direction means from node 6 to node 1, we have to add the lowest capacity, which is from here, node 6 to node 2, which is the arc is 2. We had to add the 2. From node 2 to node 1, the arc here is 1, so we had to add the 2. So that's why we have 4 and 3 here. So we have our first iteration. This is our new path, so we have to adjust our network. After this, we have to repeat all those steps in other path. Our next path here is from node 1 to node 2 to node 4 to node 6. So we repeat those steps. Find the lowest capacity of this arc. The arc here from node 1 to node 2 is 1. 2 to 4 is 1. Node 4 to node 6 is 1. So obviously, the lowest here is 1. And we had to adjust, add and subtract. That's why we came up with this. And so on and so forth. Our last path here is node 1 to node 3 to node 5 to node 6. So that's why we come up with this. But our objective here is to find a path that has no zero flow capacity going from the source node to sink node. But what if all the paths have at least one zero flow capacity from the source to a sink? Then that's why we can find the maximum flow by summing up all the lowest flow capacity. Therefore, from node 1 to node 2 to node 6, we have 200 flow capacity, while in node 1 to node 2 to node 4 to node 6, we have the lowest here is 100 flow capacities or cars per hour, while from node 1 to node 3 to node 5 and 6, we have 200. That's why we come up with this 500 cars maximum flow for this network. So this is the total. Another way to get the maximal flow is by using the linear programming. Linear program, it is derived from a maximum network flow problem that has a large number of constraints. So how to formulate a max flow problem as a linear program? So first, you have to introduce the variables to represent the flow over each the edge of the network. By the way, this variable means flow from node I to node J. So our goal here is to maximize the flow from node 6 to node 1. Also, we have two types of constraints, which is the capacity constraints and the flow conservation constraints. Capacity constraints, it is the flow over any link cannot exceed the capacity of the link. So, like this, the flow from the node 1 to node 2 is less than or equal to 3 units. And next is the conservation constraints. It is the flow conservation constraint that is valid for nodes other than the source. So the total flow flowing into a node is equal to total flow flowing out of a node. So here, the first formula, from the flow of node 6 to node 1 is equals to the sum of flow from node 1 to node 2, flow from node 1 to node 3, and node flow from the node 1 to 4. So you can get the maximum flow by getting this manually, but nowadays we have a Excel solver or QM for Windows. It's just like this. So it is very convenient and you can save more time by using this. So that is all for the maximal flow problem.
Hello, Directioners! Gising pa ba ang all? Finally, we're on our last location, which is the shortest route problem. So shortest route problem, as what the name implies, it determines the shortest route between one point of the network to another. So one example of this is the Waze app, where it provides users the shortest route possible in going to a destination. So we have here the shortest route technique, which is the Dijkstras algorithm. Later, we will also learn how to use software applications in solving the shortest route. So the Dijkstra's algorithm begins from the node to be selected, which is the source node, and it examines the entire graph to determine the shortest path among that node and all the other nodes in the graph. The algorithm maintains the track of the currently recognized shortest distance from each node to the source code and updates these values if it identifies another shortest path. So once the algorithm has determined the shortest path amid the source node to another node, the node is marked as visited and can be added to the path. So this process is being continued until all the nodes in the graph have been added to the path, as this way a path gets created that connects the source node to all the other nodes following the plausible shortest path to reach each node. So to better understand the Dijkstra's algorithm, let's have a sample problem. So let's assume na naman, that One Direction will have a concert in one of the cities on England. Ipalagay natin na they are based on City A and they will have their concert on City G. Of course, bago maka-arrive sa City G, may other cities pa silang madaanan. Let's name those cities as letter B, C, D, E, and F. So this is the summary of the data. So from City A to City B, may 5 kilometers na distance. City A to City C, may 3 kilometers, and so on. So please take note of this, or better screenshot it kasi we will use this data later. As you can see, naka-indicate na in every path yung distances. So our goal is to arrive at City G using the shortest route possible. Using Dijkstra's algorithm, we can find what route should be used. Since ang origin natin is City A, yun ang unahin natin i-identify. So node A is connected to node B, node C, and node D. Then, we are going to compare their distances. path AB is 5 kilometers, path AD is 4 kilometers, and path AC is 3 kilometers. Alin sa tatlo ang may shortest distance? Obviously, it's path AC, which has 3 kilometers. So we will mark it as visited path. I-darken lang natin yung arc. However, it does not mean na yun ang final path na gamitin natin kasi baka mamaya shorter pala ang path ABDEG or path ADEG. So later pa natin malaman ang final route. Kaya on the next step, isali pa rin natin sa choices ang path AB and path AD. So notice that we ended on node C, right? Sa next step, i-continue natin ang path ng AC. I-connect na natin sa node E and node F. So yan, we just copied the previous paths and nag-add tayo ng node E and F sa visited path natin. So path ACE may total distance na 9 kilometers, while path ACF has 10 kilometers. So compare again, and ang may shortest distance sa apat is path AD, which is 4 kilometers. Okay, establish natin ulit. So ito na yon, yung kanina. Since we ended on node D, connect na natin siya sa node E. Okay, so diba sabi ko kanina, we will just copy yung mga path na hindi pa visited kasi may chance pa na sila ang shortest route kasi di pa naman tayo naka-arrive sa node G. However, in the case of path AB, do we still have to copy it? The answer is no. So why? Kasi common sense na lang if we compare their distances. From path AB, mag-end up lang din siya sa node D. So maging path ABD, which has a total distance of 6 kilometers. Samantalang meron namang path AD na 4 kilometers lang. Siyempre, doon na tayo agad sa path AD. Mabalewala na yung path ABD kasi hindi na siya ang shortest route. Now let's connect path AD to node E, which has a total distance of 6 kilometers. So copy the previous paths ACE and ACF. Compare the three paths, and the shortest distance is 6 kilometers, so we will go with path ADE. So next, we will complete the path. So path ADEG, ang total distance niya is 15 kilometers, and path ACFG has 18 kilometers. So by the way, yung path ACEG, kasali pa yan siya, hindi ko lang nalagay sa PowerPoint. So ang total distance ng path ACEG is 18 kilometers also. So the path with the shortest distance is path ADEG with 15 kilometers. So to better visualize the diagram, ito na yung final route. The shortest route that one direction should take is from city A to city D to city E and finally to city G. So ganun lang kadali ang Dijkstras algorithm. So next, we will learn how to solve shortest route problems using the QM4 Windows software. So we will use the same examples, the same data, but we will change the letters to numbers. So instead of letter A, it will be number 1. So letter B is number 2, letter C is number 3, and so on. So first, open the software, then punta sa module na tab, then click networks, and then click the file tab, then new, and select the shortest route. After that, may maglabas na ganito. So provide all the information needed, lagay natin sa title, concert. The number of branches or number of paths, which is 9. So yung number of branches natin kanina, ito yun From city A to city B, 1 branch. City A to city C, another branch. So ang total niyan is 9 branches. And then, sa network type is directed, since this is one direction. Charot. Kasi from node 1 to node 7 lang tayo. May direction ang puntahan natin. And then sa row names, kahit ano lang dyan. And then click OK and maglabas to. So input lang natin yung origin, which is from node 1, and then ang destination is node 7. And then input natin yung given data, the start node and distance. And then click solve and maglabas na ang result. So ang napiling path is branch 3, 7, and 8. So yan. So path AD is branch 3, path DE is branch 7, and path EG is branch 8. So yun lang, very easy ang QM4 Windows method. So next, we will learn about linear program for shortest route problem. This formulation assumes that an external unit of flow enters the network at node S and leaves at node T. So, bale, ang origin node is S and destination is T. We have here the variables x sub ij, which is na-discuss na sa previous topic, and c sub ij, which refers to the length of arc ij. So, itong c sub ij, ginagamit lang siya if may available na data, other data, like another variable. In our case, we only have one, which is the distance. So the equation for the shortest route is minimize z, which is equal to the summation of all defined arcs of c sub ij and x sub ij. So we will use again the same example. Now let's look at the table. Sa column A, nakalagay dyan yung nodes natin from 1 to 7. Sa first row naman is the variables. Since ang goal natin is makapunta sa node 7 galing sa node 1, lagyan natin ng integers showing that we will leave from node 1 and arrive at node 7. So kung nag-wonder kayo saan galing yung negative 1, positive 1, and yung 0, constant yan siya guys ha. Kasi sa linear programming, ang node S, which is node 1 sa atin, is may positive 1 na integer, showing that it is the origin node. And sa node T naman, which is node 7 sa ating problem, may integer na negative 1 because it is the destination node. So sa column K, may positive 1 sa node 1 and may negative 1 sa destination node natin, which is the node 7. And then 0 naman ang sa node 2 to node 6 because we will not stop in those nodes. Daanan lang natin yan sila. So same lang din sa variables na x equals the arc of I, j. So sa I, lagyan natin ng positive 1 and sa j, lagyan natin ng negative 1. So kung makikita niyo sa baba, yan ang equation natin sa shortest route. Yung minimum z is equal to the summation of x sub ij and c sub ij. If you can notice, yung distance in kilometer, constant siya ng variables. On the previous topic, sa linear program for maximum flow, na-discuss din yung constraints that the inflow of one node is equal to its outflow. So in our case, sundin natin yung constraints na positive 1 on node 1 and negative 1 on node 7. So kung ilagay na sa equation, ganito na ang result. Now we will solve the shortest route using Microsoft Excel. So take note nyo yung constraints kasi magamit yan mamaya. So first, we will make two tables. Sa first table, dito natin ilagay yung given. Same lang to sa Dijkstras Algorithm na example. Okay? Since given na, input na lang natin ang data and merong isang column na for decision variable. So ang result dito is binary numbers only. Kung 1 ang maglabas mamaya, ibig sabihin, yun ang path na napili. Yun ang shortest path na gamitin. And if 0 naman, it means that we don't need to use that path. So later, malalaman natin ang results. Sa other table naman, dito natin lagay yung constraints. If you still remember, ito yung sa equation kanina, di ba? Our goal here is that yung total outflow ng one node minus its total inflow, dapat mag-equal siya sa constraints. So to get this, we will use a formula. Sa outflow and inflow, we will use some if formula. Sa outflow, ang goal dito is mabilang or malaman natin kung ilang beses naging decision variable ang isang origin node. So to get this, we will encode the formula sum if, then ang range natin is lahat ng start node. Then ang criteria natin is yung node 1 muna, tapos ang next range kung saan mag-base is cell D3 to D11. So if you notice, may mga dollar signs sa formula. Kung maalala nyo, we have learned about this symbol last semester. So this is para hindi mag-move ang cells if ever i-drag natin ang formula. So we will copy the formula from node 1 to node 7. So ganun din ang formula for the inflow, pero ang gamitin natin na range is the end nodes. Sa net column naman, minus lang natin ang inflow sa outflow. Then copy the formula hanggang node 7. So ang goal ng net is dapat equal sila sa balance or sa constraints. Ang result ng net column is nakabase sa outflow and inflow na nakabase rin sa decision variables. So lastly, we will encode a formula for the final answer, which is the total distance of the shortest route. So to compute this, we will get the sum of the product of the distance and the decision variables. After that, we will solve the problem using the Excel solver, which can be seen on the Data tab. Sa set objectives, we will select the cell H12 or yung cell na may formula ng total distance. Then set natin to minimum kasi shortest root problem nga. Tapos sa changing variable cells naman, dito yung decision variables kasi dun maglabas ang result mamaya. Then click add para maset ang constraints. Sa cell reference, highlight natin ang net column and sa constraint, highlight natin ang balance column. Then click OK, tapos set natin into simplex LP ang solving method and click solve. So yan ang result. As you can see, may tatlong 1 lang sa decision variable which is the path 1 to 4, path 1, 5, and path 5, 7. So it means na ito yung shortest route na na-solve. And ang total distance is 15 kilometers which is the same sa Dijkstras algorithm. So let's observe the other table. So sa node 1, may isang result lang ng outflow and 0 result sa inflow niya. So if we compare sa decision variable, isang beses lang naging decision variable ang origin node na 1 and never naging decision variable ang origin node na 1. So same lang din yan sa other nodes. And as you can see, equal yung net and the other constraint. So this is the final answer. The minimum z is equal to 15 kilometers, which is from x sub 1, 4, x sub 4, 5, and x sub 5, 7. So linear programming is helpful for obtaining the most optimal solution for a problem with the given constraints. So in linear programming, we formulate real-life problems into a mathematical model. So that's all. Thank you, Directioners, for joining us on tour.